video is on neutralization reactions. Neutralization is a reaction between an acid and a base. When these two react, the products are always a salt, which is another name for an ionic compound, and water. So an acid-base reaction is a double replacement reaction, which we know from before. We have AB plus CD, and my A and my C swap places to make CB and AD. We can also write acid as HA because all acids have that acidic hydrogen on the front. And then bases always end in hydroxide except for ammonia, so we can write BOH. When they react together, my B and my H, so the metal on my hydroxide and the acidic hydrogen on my acid, are going to swap places to make Ba plus HOH. So that Ba is my salt, or my ionic compound, made from the anion of my acid and the metal cation from my base. And then my other product is water, which we can write as HOH, or you can write as H2O. Either one is fine. Balancing wise, it's easier to write water as HOH because then you have your hydrogen from your acid, the OH from your base, and it's easy to count them up. If I have a strong acid and a strong base, they're more than likely going to cancel out and be neutral in water. So that neutral would have a pH of 7. Now, if I have a weak acid and a strong base, my strong base is going to outweigh my weak acid. So I'm going to end up with something called a basic salt in water. So that means here my pH is going to be greater than 7. Salts can be acidic, basic, or neutral. So the opposite of here would be a strong acid and a weak base, where here I have an acidic salt in water. In this case, my end would have a pH of less than 7. So it's important to note that neutralization does not mean a pH of 7. It can be higher than 7 or lower than 7, unless I have a strong acid with a weak base. A strong acid and a strong base. So let's go ahead and write our formulas. So if I have phosphoric acid comes from phosphate, and then phosphate has a charge of -3, so I have 3 hydrogens on the front. These are my acidic hydrogens. So I have H3PO4, and acids are always aqueous, plus barium hydroxide. Barium's in group 2, so it's a charge of +2, and hydroxide is -1, so I get BaOH2, and that's also going to be aqueous. My barium and my hydrogen are going to swap places, so I have BaPO4 and HOH. Now, on my salt, I need to check my charges because it's an ionic compound. Barium has a charge of 2, phosphate -3, so I put parentheses around. Swap and drop, or crisscross down, 3, 2, and now I need to balance. 3 hydrogens, 1 hydrogen, so I put the 3 here. 1 phosphate, 2 phosphates, so 2 in front. 1 barium, 3 bariums, 3 in front. 3 times 2 gives me 6 hydroxides, and I have 1 by 3, so that means instead of a 3, this needs to be a 6, and then I'm balanced. Water, in this case, is a liquid, and this we check our solubilities to see if this is a solid or aqueous. My next one, I have hydrochloric acid. Hydroic comes from chloride. Chloride is a charge of -1, so it's just HCl. That's aqueous. Sodium hydroxide. Sodium has a charge of +1, so NaOH, again aqueous. My sodium and my hydrogen are going to swap places, so I get NaCl and HOH. Again, water, a liquid, and this I know is aqueous.